Oops. Okay, no questions. Let's go ahead. So now what we're going to see is something that we discussed at the beginning of the session. We are going to design a skyscraper, let's say. We're going to design a skyscraper on the fly without any preconceived sketch or idea. It's just going to be a tall tower, a high-rise building. Let's say it's going to be like something like a mixed-use building. So you have probably have something like some commercial spaces on the lower floors, and obviously you'll have some residential blocks on the upper floors. Uh, of course, since this is a high-rise building, it's going to have a glass facade, probably something like some little exoskeleton as well. So yeah, that's sort of the brief right now. I would say that the ground coverage is going to be something like circular space of let's say a 25-meter radius circle. Okay, so that's what I'm going to start with, and let's say it's going to go for 200 meters. So although I'm talking in meters, and as you can see that my model is still in millimeters, we are just going to take the millimeters as a referential scale for now. And if you want to use it for precise dimensions, we'll see how to scale it and stuff. Okay, so let's get started. I'm just going to start with a circle, and then let's see how things move ahead. We'll also see how we will try to minimize the human intervention on this. I mean, yes, you would obviously require an advanced software such as Grasshopper to reduce human errors and intervention to the max. But here we will just try to get by just with Rhino and see how we can do it with minimal drafting, let's say, and we'll use mostly the power of the software to give us the curves that we want, or the shapes that we want. Okay, so let's get started. We start with the circle as decided and agreed upon by everyone over here. So I'm going to go with 25. Okay, and I'm just going to move it, copy it to a height of 200 as we all decided before. So this is the entire tower, and this is what it's going to look like. I mean, if you can imagine, this is its entire scale. So let's go ahead and make some modifications. The first thing I'm going to do is rebuild it to have equidistant control points and something that I can control, basically. So I'm just going to take 8 points and a degree of 3, just like we always do. I'm also going to make sure that I have said delete input, because I don't want redundant copies of something made on top of each other. So that's the whole deal. And we hit OK, and we have these 2 curves. Now, I'm just going to transform, just modify the control points a little bit so that the shape looks something amorphous. I'm not going for something precisely that I want, but the whole idea is I don't want to keep it symmetric. I want to have some undulations on it. So when I loft the whole thing, there is some drama on the surface and it's not very regular. Okay, so let's just select. I'm just selecting diametrically opposite points and then scaling them, which still keeps it sort of symmetrical. But now let's see, I'm just going to make some changes here and there. Okay, and then yeah, so it's still, oops, still somehow has the initial initial idea, and now okay, that's enough tampering, I think. Okay, I'm just going to move this guy so it doesn't have a flat surface. Okay, so this is what we're going to start with. This is the ground floor, the base of the structure. The top, I'm just going to make it as small as possible. So firstly, I'm just going to scale the whole thing by pressing shift so that it gets scaled uniformly. So I have this thing, and I'm going to make it somehow maybe, slightly sharper than what this thing looks like. So that's just some intuition that I have, but I'm not sketching anything. I'm just using the control points to achieve the desired shape to some extent. So none of my decisions are informed by any any functionality or even climate analysis or the context or anything. So this is just some stupid sketching, but in Rhino, okay, using control points. Digital sculpting, as we call it. Okay, so I'm just making potatoes. Oops, I don't want to change the axis yet, so I'm not moving anything. Okay, this is fine. This shall do. So now I have a bottom curve and a top curve, but if I just loft it now, it's just going to be something like a pyramid, and that's not what I want. I want some undulations on the surface as well. So it's not going to be like straight or slanted, but it's going to have some curves on the cross section as well. So to do that, I will need some more curves, but to get those curves, I can just say tween curves, which is what we did in the first session. So these are the tween curves. Right now, we just have 3. So yeah, that's okay. We can make do with 3. So tween curves, as you remember, is a command to give the curves between 2 curves. These new curves also show the transition from the first curve to the second curve. So this is what it shows, basically the transition of how the first curve becomes the last curve. If you increase the number to something like 10, so now you can see the defined curves in a more nicer way. But now I'm just going to keep it something like 3. Okay, I hit enter and I have these curves. I'm just going to rotate them around. Oops. Yeah, this is how you rotate. Now, since my ortho is on, it's just rotating on by 90 degrees orthogonally, but I'm just going to put ortho off. So to do that, I'm just going to press the hotkey F8, which allows me on the fly to control the ortho. Okay, so this is how it's going to be. I'm still going to keep it slightly fatter so that there is more volume at the base and then it becomes narrow. This one I'm going to rotate as well so that it has slightly different geometry, and then I'm going to scale it. And I'm going to make sure that this this cross section begins at a slightly lesser height. So we have something that goes very sleek at the top. And the middle bit, let's say it comes down a little bit and also slightly rotated, slightly deformed. Okay. So there is some logic. It's not like it's absolutely bonkers what I'm doing. It's just not the traditional way, I think, to design. Oops, I'm going to press shift. Okay, oops, too much. Yeah, there we go. We have the curves. Now, I hope you can imagine, like, since you know how loft works, I hope you can imagine that these are cross sections of a tower, and it's just going to be a lofted surface on top of it. So, okay, let's go. Loft, and we're going to select them in the right sequence: 1, 2, 3, 4, and 5. I hope I selected the topmost one on the right side, but here we can still change things over here. So I'm just going to change this thing to this part, and yeah, I think the rest of it looks pretty okay to me. Okay, let's hit loft. Ooh, something weird has happened. The surfaces are, no, it's okay. It's not too bad. I mean, since it's tight, it 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 seems like the surfaces are inverted, but not really. I mean, you can see through and through, like you can see the base. So it's not like the surfaces are self-intersecting or anything. It's just that they are slightly steep. So to deal with that, we can say rebuild with more control points, more. We have this weird little bulge at the base, and this is too narrow. So we're just going to hit cancel, slightly make some changes. This guy can become more in volume, and so can this. Okay, and this one can slightly reduce. So there is a smooth transition over here at this point. Okay. Now, loft. 1, 2, 3, 4, and 5. And everything seems fine. And yes, okay. This is not exactly what we were looking for, but yeah, this should do. The seam is aligned. There is nothing wrong in the geometry, and everything seems fine. It's just that the OpenGL is displaying it in such a way. But let's just go ahead and hit OK. So there we go. That's the surface. It is ghosted for now. You can see all these curves on top of it, which is because the surface iso curves and the edges are on. So yeah, this is how the surface is. Okay, now let's go one step ahead and then make some modifications, some fun modifications. So now we have this surface, which this tower, which is absolutely amorphous. It probably has no sense at all to be habited by people, and it's going to be a huge task to functionalize this absurd form. But yeah, well, let's make it slightly more interesting, and let's see how this shape can be played with in a more digital sculpting kind of way. So first thing I'm going to do is I'm going to try and bend this. So I want since it's so plastic, I want to bend it in one of the directions, and then we'll see how we can twist it. So let's try the bending first. The bend command needs an object. Okay, so this is the object. Now it says spine, start of spine. So a spine is sort of the an axis which is very flexible. So it's not a very rigid vector kind of an axis that it just shoots up in one direction, but it is a flexible kind of axis. So we're going to say what the start of this spine is. To do that, we will get some help from one of these snapping tools. So I'm going to say just keep the center snap on. I did that by right clicking on it, as you might remember. Well, it's not appearing, so I'm just going to press quad as well, so it understands which curve I'm talking about. Well, yeah, it's going to be somewhere here. So that's the one, the first, the start of the spine. And for the end of the spine, I can just click on it again. I need to make sure that the point snap is on. Control click on it, and now, oops. And now I'm going in the Z axis. So that's where the spine ends. Okay. Now it asks me, where do I want to bend it? So as you can see, I can just bend it in whichever direction, however I want. So that's how it's going to remain. It's going to maintain the same curve that it has, and at the same time give me the desired effect. So I will go in one of the views. So let's say I'm going in the front view, and I'm going to say that, okay, don't bend too much, maybe just so. Okay. So that's where we stand now. So we started with these curves, but now we are somewhere over there. Okay, fine. At this point, I'm just going to go ahead and make a copy of it. And then we're going to play with it a little bit more. So we have bent it. It is bent. So it's not like it is tilted. It is bent because we gave it a spine. So that's the thing about it. To tilt it, you would just select it and then just rotate it. But no, we have bent it. So this is the bent geometry. Now let's twist it. So let's understand what a twist is physically. So when you say you want to twist something, twist an object, that is, what you would do is hold it on either sides, keep one edge stationary, and the other one you would rotate. That's how you twist it. So you hold it on two sides, one side is stationary and the other side is rotated. That's how you twist it. I'm not going to twist my phone, and of course. So let's understand what twist the command asks us to do. Twist. Select the objects. Okay, this is the object, and it's selected. Start of twist axis. Okay, so this guy needs an exact axis, and we don't have any reference points. Well, let's use this one because I have the reference point for this. The reference point is 0, 0, 0. Okay, so I'm going to say twist again, select this object, and the start of the twist axis 0, 0, 0, because that's the base. End of the twist axis, I'm going to go in one of the views again, and I'm going to say F8 for sure, so it helps me. And let's say I'm going to use this curve. If I can somehow find its center. Yeah, somewhere over there. Yes, this is the one. So end of twist axis. Okay, now we have the axis. So we have established the two edges, and now we will rotate one of these edges. So let's do that. I'm going to hit F8 again so that I can twist in a more free way. So this is how it is going to twist. Let's say I'm going to twist it by 180 degrees. Okay, let's not pick some reference point. I'm just going to type the angle. So you have the option of typing the angle, the rotation angle, or you can pick a point randomly, just like in bend. Okay, so I hit OK. It takes some time, of course, because bending and twisting takes time. Okay, and there we go. That's the geometry. That's how it looks. So the original was just a thing, and then we bent it, and then we twisted it. I'm just going to bend it slightly back. Oops. Because that's the whole point of sculpting. Like, you like something and then you just want to fix it a little bit, but here you're not playing with a very amorphous material like clay. You are dealing with surfaces in the form of forces, actually, because how a curve is behaving in one direction is going to drastically affect the other curve on the other side and the surface as well. So here, this is like digital sculpting 101. Oops, 0, 0, 0. Start spine. The end of spine would be, oops, would be somewhere over there. And then no, we need to go in the front way. So there is a subtle bend that we are going with, not too much. So yeah, this is the shape that we have. Okay, that's fine. Now we're going to go ahead and add some more things, some more objects to this geometry to convert it into an architectural design project. Okay. So until this point, if you want to go ahead and try it yourself, you can have some time, just make something, try to bend it, twist it, and if you have any issues, let me know. Okay. So let's move on for the next part, because I think, yeah, okay. So now that we have this amorphous looking object, which basically that's what it is, it's just an object now, and we still need to play with it a little bit more to understand how things are going to be taken care of in an architectural design context. So this is the object that we have. First thing that we need to do is understand what these curves are and how we can extract them to then detail out specific parts of the entire geometry, and then maybe extract a specific piece from it and then work on it and then put it back in, and then the whole thing then comes out. So first thing that we're going to do is uh, see where the floors are going to be. In that process, we will also take the boundary curves for all of these floors. So to do that, we're just going to use the contour command, which will help us in taking out all these curves at regular intervals. So I'm just going to say contour, select the object. Now, contour plane base point. So it needs a base point for the plane at which the contour begins. Okay, so it could be anywhere. To use the contour command, it is always better to go to the front view or the right view, whichever is has an unobstructed view of the entire building. So I'm just going to go to the front view, and I'm going to pick the point exactly as it's at its base. So that's the base point. Now it's asking for the direction perpendicular to contour plane. So basically what it's asking is, where do you want to start cutting, and then in which direction you want to keep cutting. So you want to keep cutting in the Z axis, but it needs a direction. So we're going to give it the direction, and the direction is going to be this. If you need more help, just press the F8 and it'll always point north. Okay, so now it knows in which direction to cut, but now it wants to understand at what intervals it needs to cut. So we're going to say, let's say, because we said that the total height was 200. So this is roughly 200 now because we bent it a little bit. So let's say it's 200, but we're going to cut it at 4. Okay, so 4 is what we say. Now you'll see that it is generating these curves. Basically, it's cutting the whole geometry and extracting only the end points of the curves. The extreme curves, I would say. It'll take time depending on how many, what is the interval that you want and the complexity of the surface. So, and of course, your processor speed. So now that I have these curves and they are already extracted, what I'm going to do is I'm quickly going to make a layer over here and just name it contour curves. Okay, and I'm just going to put all these curves in this layer. So later on, when I want to operate onto them, I can simply just go into this layer and do whatever I want. Okay, so we have all these layers now with us. Let's say we're also going to say that the surfaces, I'm going to call it tower surface, and the tower surface, I'm just going to keep it in this layer. So we have all the curves with us. Let's make floors now. Now that we have the curve, the floor is going to be very, very easy to make. All we need to do is make a surface on this boundary curve. Okay, so there is a very simple command for it. It's called as planar surface. It only works for planar curves. If your curve does not have just one single plane, if it's slightly curved within itself, then this command won't work. But in this case, it will, because we know that all of these curves have their individual planes and it's just one plane. So I'm going to select all of them, and that will make their individual planar surfaces. So there you go. We have all the planar surfaces with us, and these are the floors. So if you say this is the surface, the exterior of the building, these are all the floors. And then you can just output these floors to your AutoCAD or even here in Rhino, and then you can just do the internal planning of it, decide where the core is. Obviously, you will start with the core and then build around it, and then you will see how to optimize on each floor and such and such. But yeah, this is a pretty decent amount of work that is being done on this now. And okay, there we go. The contours are back on. So we have the floors, and we just need to now understand how to play with the surfaces. I'm just going to put the I'm just going to say floors, and I will just put all my surfaces into this layer. So I have the floors with me, and now let's see what we can do with the other floors. Now I have the bottom floors, but let's say I don't want them to be like at the interval of 4 meters. I want them to be slightly more higher floors. So I'm just going to delete some of these. Am I in ghosted view? Yes, I am. But for some reason, I cannot see the surface edges. Yeah, that's why. So with the surface edges on, I am going to just select some of these floors and just delete them, because I'm going to do something else for these floors. So these floors are probably, as we decided earlier, these are probably some commercial floors. And then we have this. So now on these floors, I need a different kind of facade, let's say. And for the other floors, the facade is going to remain whatever. So for these floors, I will extract this surface, the part of the tower, and then I will work on it. So to do that, what I think I'm going to do is I'm just going to split it. Yeah, I'm just going to split this whole part into the whole into a chunk and then design on it. But to do that, I have the curves which I'll use to split. So let's say I'm going to say split object this, and the curve is going to be, oops, not this. Yeah, this one. And okay, one poly surface split into 2 pieces. So now I have this little chunk. I'm just going to move it by a predetermined amount. Let's say minus 50. No, I'll have to move it by slightly more. Minus 100, let's say. Okay, so I have it on this side. And when I'm done working on it, I can just move it back in by 100. So that's a very basic thumb rule that I'm going to follow. Now I have this surface with me, and I'm going to make something like a facade, but something like an exoskeleton on it. Okay, so probably this floor will not have a facade, but probably just going to have like a structural system without any membrane as such. Probably, I don't know yet. I'm just designing on the fly. So how do I do that? Am I going to make these lines and then make a pattern onto it by joining all these lines, and then probably something similar to what we did in the canopy? Well, the canopy was easier because we had fewer points and a surface that was not a double curved surface. But here in this case, it's going to be slightly complex. So what I'm going to do is I will flatten the surface out into a base surface. I will work on on the base surface, and then I will take everything back on my curved surface. Okay, so to understand this, what basically I'm going to do is, if I want to do something onto the screen, let's say, and on this curves, I'm just going to take this material out, flatten it out, and then do whatever I want, and then put it back in. So let's say I want to engrave my name. I'm not going to engrave it on it. I will take it out, flatten it, engrave it, and then put it back in. Okay, so let's do that. So to flatten it out, there are several commands here where you can say unroll or smash. So we're going to use smash because this is a double curved surface. So I'm just going to say smash. Select surface or polysurface to smash. This one. Do you want to explode it? I'm going to say yes for now. Oh, okay. So I exploded it. So because I exploded it, it has exploded it into numerous constituent parts. I'm going to say no, don't explode it. Let's just say smash again, and oops, did you smash it? No. Explode? No. And now do it. Okay, so it did not explode this time. So there we go. We have it. So now it's flattened out, and we have it like this. There is a little part here which is which will obviously be there. Also these parts which are slightly overlapping on top of each other. But yeah, we can use all of this to make something and then put it back in. Okay, now another thing that I'm going to do here is I need to understand how these lines are, as in this is a surface, a polysurface, but it has some surface isocurves on it like this. So these surfaces are all different now because they have been lofted and they have been twisted and whatnot. So it has stopped from being one homogeneous surface, and it has broken into a lot of surfaces which don't share the same morphology, unfortunately, and which is why it has given something like a shabby collage of a lot of surfaces. In this case, I would just go back and draft it in a more smoother way. Draft it as in modify things in a more smoother way, and then loft it again, twist it, blah, 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 and then come to this point. But that's okay. I mean, it's just a process. Let's understand how the flow along surface works, and then probably that's going to be more useful. So let's pick one of these surfaces. Let's say I'm going to pick this one because it has lesser subdivisions on it, and then I'm going to make something on it, and then we'll see how it looks on its parent, just to see if this is still behaving in the same way that I want it to be. I'm just going to make a certain this is just a test to see if it still behaves in the same way. So this is a curve. Okay, that's the curve. I'm just going to move it slightly up. Let's say by by 2. So that's where the curve is now. And let's see if we can have it on this. So we're going to use flow along surface. Select the objects, to flow along the surface. So basically, that's what we are doing. We have smashed it, we have it on the ground, and now we are doing something on it. And then we're going to say, hey, whatever we have here, just flow it along the surface. Okay. So select the objects to flow along. This is the object. Select the base surface. Now, we don't have one single base surface, so it's going to be slightly trickier than what we initially thought it to be. So yeah, this is a base surface now. And now it says, okay, which is the target surface? So I'm going to have to look for its target surface. I think it is this one, but yeah, that's just going to be a guess. Yeah, maybe it's you. So yeah, you see, that's how it's going. So yeah, let's try to smoothen things out at this stage itself, and then go back here and then see how things go. Okay, because it's not going to work in the same way as we had anticipated before. I'm not going to trash anything. I'm going to use the curves that I have from before and follow a similar process. So let me just rebuild them to have equal sort of subdivisions. I'm going to say something like 6, and I'll keep it at 3. So it's slightly more smoother because the subdivisions have made things relatively smoother than before. I have lofted it again, and there we go. This time I'm going to keep it uniform so that there are no unnecessary. Oh, am I splitting at tangents? Let me see. Because it's still having the same problem. Just making sure that the curves are aligned. No, I'm not splitting at tangents. It is uniform. There is something happening here, which will probably give us some issues later. I'm going to say rebuild. Okay, yes, and now we have a clean geometry without any edges. So yeah, I think we were having a lot of control points on it, and which was causing the whole problem. So I'm just going to copy this, and then we will twist it. Twisty. Yeah. Making sure I'm in the ground plane. And I'll go in the front view. Okay, that point should be okay for now. And just a 180 twist. Okay, so you can see that the seam is now moving, is being rotated on either side, and now I'm just going to bend this whole thing. Start of the spine again. I'm going to go in the top. Project is on. Go in the front. The end of the spine, and then I'm going to bend it. I'm going to bend it like Carlos. Okay, so that's the geometry now. It still looks shabby, but yeah, let's make do with what we have. There's the fun of iterations. So now let me do one thing. I'm just going to trash this whole thing because it's of no use. Change object layer. So we have this, and now we're going to follow the same process, and we will just contour it. So and contour. So I went in the front view and I'm contouring it now, making sure that I have taken the base correctly, the direction is such, and the distance is still going to be 4. So as you can see, it doesn't really respect the ISO curves. It's just going to cut it, chop it off at the distances, but in the orientation of the plane, which is XY. So these are the curves. I'm just going to put them in, okay. In the layer, and then I'm just going to hide. No, I'm just going to delete this because I don't want it. So I have the contour layers with me. This is going to be my surface. This is the tower surface. And these are now going to be my new floors. So here we go. Floors, change object layer, and there we go. We have the floors. Okay. So you're going to follow the same process and delete the floors. So these floors are now deleted. We go back to the tower surface and let's split again. Hang on, I forgot. Okay, this one is the one that I'm going to use. So I'm going to say split. What do I want to split? I want to split, hey, no, not you. I want to split the surface. Split the surface, yes. And the cutting object is this. Okay. So now it's split. I'm going to move it. Sorry, I'm going to move it by 100. And now we're going to follow the same process. And we're going to say smash the surface. And it doesn't matter if we explode it or not, because it's just one single surface. So now the problem is fixed, and now we can do whatever we want on this surface, and then we just take it back, flow it along this surface. So let's try to make a pattern sort of, and then let's see how it looks when we take it back to the parent. So I'm just going to put it back in by 100. Yeah. And okay, let's see. So to make a pattern, I will need some guidelines, and for the guidelines, I'm just going to use the surface, the ISO curves of the surface. So I'm just going to say extract the ISO curves to take out the ISO curves and then play on them. But I will need some understanding of where to base the ISO curves and where to extract them from. So to do that, I'm just going to use the boundary, the edge of the surface, and I will just say extract wireframe. So when I say extract wireframe, I get all the default ISO curves of the entire surface, which will help me to do whatever I want. So, but it has given me all the ISO curves, and I don't want all of them. So I have the selection. I'm just deselecting the things that I want, and then I'm going to hit delete. Okay. So I'm just deselecting this because I want this, and I want the one in the end. Okay. So I've deselected them, and now I'm hitting delete. So I have these, the edges, as curves, as single curves. So now let's say, yeah, I don't want this as well. Okay. So this one, let's say I'm going to divide it divide into, I don't know, maybe 15. Okay, so it has 16 points. And this one, no, hang on, I don't like that number 16. Maybe we need something that is odd number. So divide this into, let's say 10. So we have 11 points. And this, we're going to say, because we have like 3 floors, I think I'm going to say 3 divisions. Okay. Yeah. Let's see. How many floors do we have? Sorry. Yeah, we have 3 floors. So I'm going to say 3 divisions. Cool. And divide into 3 segments. So we have these 3 segments. Okay, so now we know where to extract the isocurves. So I'm going to say extract isocurve, and now it's giving me the isocurves in the u direction as we discussed before. So this is the u direction of the surface, and as you can see, the curves are rotating as the surface is made. So I'm just going to extract all of them. 1, 2, 3, 4, 6, 7, 8, and 9. Okay, and I need the other direction. So I'm just going to say toggle. Okay, so I just press T and hit space. So it has now toggled my direction, and we have these guys. Okay, seems cool. I'm just going to select these points because they are of no use now. Just going to put them in trash. Change object layer, yes please. And I'm going to select these curves and probably yeah, move them by let's say 2. So let's understand what is going to happen. Like whatever we have here on this surface is going to be on this surface at the same distance and following the same geometry. But let's understand, this is the seam, and the seam is exactly where the surface is being unrolled. So the seam is this edge and this edge put together because they are being glued to each other. So whatever happens here and here is going to overlap on each other. So we better have just one of those, not both. So I'm just going to remove this. And now let's just play. Let's just make whatever you want to make. I think I still have those points. Yeah, those points are there. So let's just, I think we are running short of time. So I'm just going to, oops. Oh yeah, project is on. Always keep in mind that you keep the project button on when you want to project geometry onto the C plane, but on other times make sure that you have it switched off. Okay, let's say this is the geometry that I want to have on the surface. So let's just give it a try. Shall we make it more interesting? Yes, please. This is not interesting at all. So I'm just going to move the control points. Oops. I'm just moving the control points to this part. So yeah. I hope I'm moving the right ones. Yes, I am. Intersection. Intersection and intersection. Okay. I need these points, but I don't have them. So what am I going to do? I'm just going to project these lines onto the surface, or I'm just going to project them onto C plane. Okay. Delete? No, don't delete. So now I'm going to make this polyline 1 and 2 and 3 and 4. And yes, we have it. Okay. Fine. Yeah. So we have this, and this, and we just need to play on it a little bit more. Yeah. So I'm just going to say trim. Yeah, trim. Cutting objects 1 and 2. And just going to trim this part. And then yes, you as well. Okay. Okay. Yep. Maybe the midpoint. Yeah, that'd be fun. So polyline. This. And this is the mid. Yeah, there it is. And the mid of this is over here. So what's going to happen is these guys are going to wrap into each other and complete the whole geometry in a way. Well, to actually be more homogeneous, we will need some more lines on this side, but yeah, that's okay. I'm just going to go ahead and make them. Okay, yeah, let's just leave it now. So this is one curve, the second curve, the third curve, and then this one. So we need to flow all of them on top of this. How do we do that? I have selected these curves already, and now I'm saying flow along surface. So since I have the geometry already selected, it's not asking me to select the geometry again. It knows what geometry it needs to flow. So now it says base surface, and it says select edge near a corner, which means it says select it as nearer to the seam as you can so that it can, understand where it needs to be pasted. And the target surface, select edge near matching corner. So I think, yeah, this should be the matching corner. And it has done it. So as you can see, it has now modified it and put it on top of the surface that we had before. So now if I go ahead and if I hide this by turning the bulb off, this is what I get. The floors and everything. Okay. How would you use this? Obviously, you would use it in a similar way to do whatever you want on the surface while it's flattened out, and then take it back to the parent surface while keeping most of its geometry intact, but also respecting the integrity of the geometry where it's going to be pasted on. Okay, so that's the purpose of flow along surface. Now, I would request you to try this on Finish Pavilion that we did the other day, where we wanted to make those holes onto the surface following the same pattern that you have on the original. So let's not follow the entire pattern as is, because it's obviously done in a more advanced way than just making those circles by hand. It is following a certain algorithm which we can obviously deal with in one of our next in the next webinar series that we have. So that is a whole different ballgame. But what we will try to do is, okay, fine, let's just make some holes on the flattened surface, on the smashed surface, and then take it back on, and then we just split and delete, or we do some Boolean operations and remove. Okay. So you guys can try this, follow the same process that we did here for the tower while the whole thing was laid down, and then do the same thing here. Just to give you a little taste, I'll show you how this thing will look when it's smashed, because this is one single object and it already has some different surfaces which are gluing to each other. So I'm just going to say smash on the surface and enter to continue. Okay. It's asking, shall I explode it? We would say yes, because if you don't explode it, all the surfaces are going to intersect into each other and it's going to be a mess. So I'm going to say yes, explode. And this is what we get. So this is, let's say, the top surface, the bottom